Problem 3.1-1. The A36 steel member is machined down from 3 inches to 1.5 inches at B and loaded as shown. Determine the deflection at D relative to A. Here's the structure. It is fixed at the wall at A. D is the free end, and there are 2 loads applied. All the dimensions are given. We have everything we need to do this problem. To solve this problem, we will need one material property of A36 steel. That is the modulus of elasticity. We can find that in a reference. And the value most commonly find for the modulus of elasticity of A36 steel and many other types of steel is 29,000 KSI. Now I'm going to draw a free body diagram. I've drawn a free body diagram of the structure and labeled it. Summing forces in the x direction will give us a reaction force at A equal to 6 kips. In the next step, I want to plot the internal resultant loads from A all the way to D. Looking at point A, there is a 6 kip external force applied, and there's no other external forces applied until we get all the way over to C. So going from A towards C, if we were to make a theoretical cut and calculate the internal force, we'd find it is equal to the 6 kips. So we have an internal force from A to C equal to 6 kips. And because that is a compression force, that has a value of -6. At point C, an 18 kip force is applied in the direction opposite to the 6 kip force. That means we get a jump in our diagram of 18 kips. That will take us from -6 up to +12. The height of that jump is 18 kips. And from C to D, we have an internal force of 12 kips. We can verify this by considering this member from D to C. If we made it an internal cut here and balanced the forces, we would find an internal force of 12 kips between point D all the way to C, and that corresponds to what we get in our diagram. That gives us confidence that it is right. The next thing I'm going to plot is the cross-sectional area, and we see that the area is constant from A to B, and the diameter is 3 inches. So I can plot as follows. The area from A to B is 7.069 inches squared. From B to D, the cross-sectional area is unchanged, and the diameter is 1.5 inches squared, and the area is 1.767 inches squared. Now I am ready to calculate my deflection. The deflection at D relative to A is equal to the sum of the deflection in the 3 segments. The first segment, we can see that the internal force P is equal to -6 kips on the diagram here. The length is 12 inches. The cross-sectional area we see here is 7.069 inches squared, and E is 29,000 KSI. For the middle section, the internal force P is equal to -6 kips from this diagram. The length is 6 inches. The cross-sectional area is shown here in this diagram, 1.767 inches squared, and E is the same. And for the last segment, the internal force is 12 kips. The length is 10 inches. The cross-sectional area is 1.767 inches squared, and E is the same. And we calculate the total deflection to be 0.0013 inches. And we're done.